Hey everyone, and welcome to this explainer. Today, we're diving into a truly monumental shift in how the world operates. We are moving far beyond basic artificial intelligence, exploring how AI is literally stepping off our screens and into the physical world to completely revolutionize heavy industry and physical asset management. So here's the question everyone seems to be asking right now. Can AI actually do more than, write your emails, draft meeting notes, or generate a neat little picture? We hear a ton of buzz about everyday generative AI, but the massive, high-stakes requirements of heavy industry demand something entirely different. We're talking about environments where a single glitch doesn't just mean a typo, it means millions of dollars lost, supply chains completely broken, or really serious safety hazards.
Here's our roadmap for this explainer. We'll start by looking at what lies beyond standard AI. Then we'll climb the maturity ladder step by step, moving through predicting and performing, into prescribing and forecasting, up to the perceptive frontier, and finally, we'll wrap up with what all of this means for the future of operations.
All right. Section 1, Beyond Standard AI Asset Optimization. Let's jump right in and define what we're actually dealing with when it comes to physical operations. Picture a massive, sprawling petrochemical plant. This is a highly complex physical environment. Industries like this are facing incredibly volatile supply chains, an absolute avalanche of operations data, and a huge push to increase sustainability. Guesswork just doesn't cut it here anymore. You need serious, physics-based digital solutions to manage these physical assets. That is the only way to stay resilient and profitable while hitting those carbon reduction goals.
So, we need to explicitly draw a line between standard generative AI and industrial AI. Standard AI, it is fantastic at chewing through huge quantities of text to write a report or generate code. But industrial AI incorporates machine learning, deep learning, and neural nets to analyze massive streams of sensor data, run hard science physics simulations, and optimize physical assets. Put simply, one writes your meeting notes, while the other stops a multi-million-dollar turbine from literally vibrating itself to pieces.
To really wrap our heads around how this works, we're going to climb a 5-step maturity ladder. Depending on budget and risk, companies can deploy AI across these 5 distinct levels to boost reliability. And each step up adds deeper, much more sophisticated cognitive capabilities to physical machines. Let's see how this builds from the ground up.
Section 2, Predicting and Performing, Monitoring the World. This is where AI begins actively monitoring and modeling its physical environment. The baseline here is predictive AI. It works by identifying super subtle patterns in massive amounts of operational data, alerting operators to deviations way before performance actually degrades. Take Petronas, the Malaysian oil and gas giant, for example. Their AI caught incredibly subtle anomalies in water supply and bearing temperatures, letting them fix a mechanical fault before it turned into a dangerous, super expensive breakdown.
Step 2 is Performance AI, which is often called hybrid AI modeling. This one is fascinating because it marries machine learning with conventional, physics-based simulation. It completely removes the guesswork by anticipating exactly when actual operations will drift out of sync with expected performance. Think of this as the brains behind industrial digital twins, giving users a true 360-degree real-time view of their operational risks.
Section 3, Prescribing and Forecasting, Offering Concrete Answers. Now, what's really cool about this next stage is that the AI stops being just a highly advanced alarm system and actually starts handing out concrete solutions.
Enter Step 3, Prescriptive AI. It goes beyond just warning you about a problem by actually identifying the potential root cause. Then, it details the specific tasks needed to assess the issue. And finally, it recommends the exact remediating actions frontline workers should take. For highly complex plants, this dramatically boosts situational awareness and prevents critical safety incidents by guiding workers straight to a resolution.
Then we hit Step 4, Prognostic AI. Imagine being a plant manager and casually asking your system, "Hey, what is the forecasted remaining useful life of my turbine?" Or, "Can we make it to the next planned maintenance without an outage?" Prognostic AI basically predicts the future. It uses generative tech to expertly weigh competing business values, like production schedules, revenue, downtime, and asset health, to find the absolute optimal outcome.
And this perfectly illustrates the so what of the entire technology, risk-based maintenance. On one extreme, you have under-maintained assets, keeping you in a stressful, constant firefight mode with unexpected breakdowns. On the other extreme, you're in comfort mode, over-maintaining assets and wasting a ton of money on preventative work you don't even need. Industrial AI helps you find that perfect sweet spot in the middle,
minimizing total cost while maximizing availability.
Section 4. The Perceptive Frontier. Interacting with humans. We have now arrived at the very top of the asset analytics ladder, where AI begins to truly interact with its human counterparts.
Perceptive AI describes intelligence that can actually interact with its surroundings. It processes sensory findings in a way that simulates human perception, allows for natural language queries, and can even initiate and manage entirely new work streams. The key takeaway here? It focuses less on automating old tasks and way more on managing brand new ones. This is the absolute leading edge. The whole idea is summarized beautifully in this quote from our sources. With Perceptive AI, users can literally just ask questions in their natural language and get immediate, actionable answers back about what's wrong, the root cause, and the best way to fix it. It's kind of like having a highly advanced, physics-aware ChatGPT specifically built for heavy machinery. It acts as a virtual engineer sitting right next to the human operator.
Section 5. The Future of Operations, Autonomous Production. We've climbed the 5 steps, but what do all these levels ultimately mean for the broader future of manufacturing?
When we apply this intelligence to a factory, we're aiming for level 5 control intelligence. At the lowest levels, humans manually control machines. But at level 5, the entire system is dynamic. Historic and current production data are used to actively and autonomously optimize schedules across multiple machines in real time. This is the holy grail, right? A smart, completely self-optimizing autonomous production facility.
But let's ground this in reality for a second. Right now, there is a massive commercial gap. There's a huge divide between what is technologically possible, like these incredible level 4 and 5 use cases we see in research labs and isolated pilots, and the standard solutions you can actually buy from commercial automation companies. The tech is there, for sure, but the industry is in an absolute sprint to figure out how to scale it commercially.
So I'll leave you with this to think about. As that gap closes, and as machines rapidly gain true perceptive intelligence, how will your physical operations evolve to keep up? Are you truly ready for autonomous production? If you want to keep exploring these crucial questions and want more deep dives into the technologies shaping our world, make sure to hit that subscribe button right now. Thanks so much for hanging out with me for this explainer, and I will catch you in the next one.